Our next presenter is Stephen Horne from KAZER Compressors, and I'm going to go ahead and hand it over to him. I know he has a great presentation ready for us, so Stephen, take it away.
Okay, thank you very much, and hello everyone. Yes, I am Stephen Horne from KAZER Compressors, and I'd like to take a couple of minutes talking to you about the products that we have to offer in wastewater industry. I'd like to start out with this machine over here to my left. This is our new EBS machine. We call it EBS.2 because it's our second generation EBS, and it represents our latest screw blower package that we brought to the market. As I mentioned, this is a second generation unit. The original EBS was the first screw blower that KAZER offered. This was way back in 2014. Certainly there were screw blowers around before then, but this is when KAZER came into the market. And the first screw blower utilized our existing low blower packages. So this new design here is designed ground up as a screw blower. And the old design was a belt-driven machine. This new unit here is a gear-driven unit. So this is a bit of a change. It allows us to, of course, make the machine more narrow, reduce the footprint, and it is a bit taller as we improve some of the design aspects and performance of the unit. Another interesting aspect of this unit is it is equipped with what we call a synchronous reluctance motor, or sometimes also referred to as a SynRim. Now, SynRim or synchronous reluctance motors are not new to the world. They've been around for as long as electric motors have been around, but they've had some issues in the past just getting them started. But with new technologies, and specifically VFD technologies, these motors are now coming back into favor, and what they offer is an improved efficiency over your traditional motor designs. The difference between this and some of the newer motors that we see out there are permanent magnet motors. The permanent magnet motor, of course, is efficient and has a lot of benefits from a performance standpoint and size. The synchronous reluctance motor gives us similar performance, but it does not require the rare earth metals. It is manufactured very much in the same way as your traditional motor. So those are some benefits there from a resource standpoint, and it gives us the performance advantage because it is also a no-slip motor. So if you combine in with the gear drive, the new motor technology, some of the other improvements that we have within this machine, this unit has now an 8% increase over our previous EBS screw blower. So as a total, this brings this machine's performance to over a 30% improvement from a performance or efficiency standpoint over our traditional lobes, or maybe some of your more traditional multi-stage machines which you have in your plants out there. So this offers you some really improved efficiencies just by switching out the machines. And additionally, these screw blowers are a fantastic fit for your aeration process. As I mentioned before, the performance is nice, but they also have an increased control range. These machines come with the VFD, so you have a nice wide control range. And what's really great about a screw blower is that the efficiency curve, if you look at it, is flat from min speed to max speed. So there's really no penalty for speeding this blower up and down. Yes, we always talk about VFDs giving you flexibility, but if you look at most machines on the curve, there is a penalty to pay from a performance standpoint as you slow them down. With these screw blowers, that curve is nearly flat, so you can really experience those improvements that we're talking about across the entire range of the unit. So no penalty for ramping it up and ramping it down. As I mentioned before, the new design allows us for a more compact machine. A swing door on the side. So this new one, all the access is done from the front. So these machines can be stacked in your installation space. So that's a nice aspect of it as well. And of course, they come ready to operate. They're complete units. They have the controller on it with a host of sensors. It's all programmed, the VFD, the controller, everything is ready for operation, and this machine is protected and, of course, as I mentioned, ready to roll. Something new that's on here, of course, the controller has various control modes within it that you might need, pressure control, speed control, but something new on our PD units is the flow control. So I mentioned before, there's a host of sensors on there. So if you're monitoring your mass flow into your basins and you want to increase or decrease the amount of SCFM coming into your basins, you can then provide that flow to the machine, and it utilizes those sensors inside to calculate if the machine needs to speed up or slow down to provide you your mass flow. So this is something new they're offering with this EBS unit, and of course this is also available on all of our complete machines with the semi-control too. And lastly, this machine can operate locally. It has a nice controller on it. It has e-stop button, start, stop. You can do all these things. You can put your DO signal in there and have it regulate if you so want from locally. But it also has a variety of communication protocols which can be integrated, different languages, which can be used to integrate into your plant PLC or SCADA. So everything that's on that controller, you can extract out. And of course, you can tell it to start, stop, as well as what speed or regulation that you're looking for. So that is all I wanted to point out here on this new machine. It's our EBS screw blower, and hopefully we can find a few more homes for these out there. The next thing I'd like to talk to you guys about is the new KAZER turbo blower. This is something new for us at KAZER that we've gotten into in the past year. It is a high-speed turbo blower package, so the impeller, of course, is directly mounted to the motor itself. That motor, as I mentioned, I was talking about, this is a permanent magnet motor. So again, this had a synchronous reluctance motor, and our turbo blower has the permanent magnet motor. Another unique aspect of this, it has an active magnetic bearing control system. So we're not the only ones out there who have magnetic bearings or active magnetic bearing control, but our KAZER turbo blower has this. Something which is unique to it is that it does not require battery backup. So of course, those magnetic bearings have a host of sensors in there, which are monitoring the shaft position, fluctuations up and down, or you speed it up and down. Those sensors are monitoring the shaft position and adjusting the magnetic field to hold it in place. But if you lose power to the site or power to the unit, you lose that magnetic field. So of course, you have to maintain power on that until the thing can come to a stop. But with our unit, we are utilizing the spinning aspect of the rotor to generate power. And then it powers the magnetic bearing system until the air can be brought to a stop. So you don't have to have a battery system in this machine. You don't have to maintain batteries. That is somewhat of a nice aspect of it as well. Another unique aspect of this machine is that the motor and the bearings are 100% sealed and cooled by a sealed cooling system. The sealed cooling system also passes through the VFD, but we're not blowing any air through the drive motor. So it is 100% sealed. So of course, if you live in a coastal area, you know what salt air can do to sensors and components, or if you a lot of our friends out in the Midwest, they deal with cottonwood season and pollen and other things, and those things can also, we'll try to prevent those from getting in on the sensors, so having it completely sealed protects those items from getting contamination. So this is a nice aspect of as well. The last thing is we have what we call dynamic surge protection, where of course it is constantly monitoring how close it is to the surge point, and should the machine get close to it, it will adjust the speed accordingly and then notify your PLC that it was not able to slow down any further than what it was told to do. So that's something new that's also on this machine. Now, as I mentioned before, it has a complete sealed cooling system, and that cooling system has an air-to-air heat exchanger as well as a water-to-water heat exchanger to remove the heat from the system. The air-to-air is a factory default. We also have this water-to-water, which is a nice solution. I like this. Of course, if you're in an area we have contaminants, but also or high ambient environment, but also if you have troubles with your room temperature in the summertime, it's often nice to turn on this water-to-water because all the heat leaves the system with the water and does not go into the room. And of course, in the wintertime, you want to heat the room, so you can just use the air-to-air heat exchanger for that. The turbo blower comes on board with its own controller, and just like we have with the screw blower, it has a multitude of control options, flow control, pressure control, as well as DO regulation, and certainly it has a multitude of communication protocols that you can use for your plant's integration. Okay, so that was the screw blower, the turbo blower. Now I want to talk to you about this item that we have here to my right. These are custom engineered solutions, or I call them the enclosure systems. What we have here is we take essentially your blower room and we build it up for you within an enclosure system. There's a nice robust base that the whole system sits on. We have these aluminum panels, which are powder coated, and they are also lined with insulation that helps with noise as well as keeping the heat and the cold out. It's a custom engineered solution, so we can pretty much build it for whatever your requirements are. In this case, of course, we have the blowers. So just like we had a screw blower, the EBS over here, we have 2 more screw blowers. Our smallest one, which is a CBS, and then the DBS is on the far side where the door is removed. So the same situation for the EBS is on these 2 machines as well, just similar, just smaller versions. Of course, we have power. You can't quite see it, but behind me there is a disconnect on the outside. This is where you bring your 3-phase power. It comes into a distribution box, which has a series of breakers on it, breakers for the blowers, breakers for the 115 volt to power things such as lights and fans, as well as louvers. So you can see here the system includes everything that you would need for a station that you might have a room. Comes already packaged and ready to operate. This thing also has a master controller. So that master controller is wired to each of the blowers. Everything has been programmed and ready to operate. If you had didn't want the master controller and just want to wire these to your PLC, we can also put a nice communication hub in here, and we can either run Ethernet cables to it, or if you'd rather do hard wiring, we can wire to that centralized hub as well. So as I mentioned before, we have on this enclosure system, we have the blowers, we have the power being distributed. We also have the potential for louvers. These louvers can be fixed. In this case, they are automated louvers, which are sensing the room temperature. So as the temperature in the room goes up, the louvers open, and as it cools down, they close. On the far side, we also have an enclosure fan. So this allows all the heat that's being rejected from these machines to be pulled out. And so it's not recycled into the enclosure. So whenever we build these stations, we work very closely with the customer or the engineer that we have in this case, and we build it up to meet the requirements for whatever process that they have. Service can also be an issue, but this machine is a cutaway. It's a show unit. So if we had service, what we would do, you would have a big wall for the enclosure here, and we put doors on it. So you can open the doors and gain access to the machines, the controllers for your maintenance. Here we can change the oil, we can change the filter, we can grease the drive motors. So you can have full access to them by opening up some access panels on the front of the enclosure. Now, as I mentioned before, once we build these, it goes into a test bay. They are fully tested. So whenever it arrives on site, the system is fully assembled, programmed, tested, ready for operation. All that's really needed is to have a power feed to the system, a pad for it to set on, and of course piping to take the air to the basins themselves. So our experience with these is that it can greatly reduce things such as your engineering costs that you might have, as well as installation costs. So we're excited about these new systems, and certainly if you have questions about them, we're more than happy to entertain them. So to quick wrap things up, here at KAZER, we're committed to our blower systems and being more efficient and more reliable. Of course, you can see that in the design of these enclosures and different products that we spoke about. These nice, of course, we talked about our screw blowers and the turbo blowers. So lots of technological advancements, as I discussed. We have our engineering solutions, which we can be made to fit your needs of your installation or your customers. And we're always pushing forward for integration, Industry 4.0, Water 4.0, all these different strategies that exist out there. We're here and ready to meet those challenges with you. And if you need more information, you can contact us or go to our website, us.kazer.com/WO. Okay, thank you.
Stephen, great job. Thank you very much. A lot of good information there. We don't have a lot of time, but I do have a quick moment here to get in one question. And I'm going to take us back to when you were talking about the EBS rotary screw blowers, and this relates to the track that we had yesterday regarding big data and interconnectivity and Internet of Things. things. But you had mentioned the Sigma Control 2 is able to work with different SCADA programs and things of that, and things like that. But I was curious, how do those systems integrate and work with plants that are implementing IoT or Industry 4.0 or Water 4.0 strategies?
Yeah, these are all fancy buzzwords that we're all coming to learn with and utilize, that's for sure. And, the big thing here is that data is data, and it does nothing unless you, A, collect it, and B, evaluate it. With our master controller, we're able to do things with it regarding maintenance, predictive maintenance, which machines to run when and how to run them. Also, we're streaming performance data from the unit so we can calculate your kilowatt consumption and picking machines and speeds to optimize your power production for air. Now, the machines themselves, if you're integrating just the machine without the master controller, of course, you see all these sensors that we have plugged in here and all the data we're collecting here. With the protocols, we provide the customer a data map, and depending upon their protocol, Ethernet IP, Modbus TCP, whatever they may have, BACnet, a module goes into here, and we provide the data map, and then the customer can extract all the data from here, and then what they do with the data is up to them. There's only so much we can do at that point. We don't have the ability to make the controls, so the customer can then implement into their strategies, whether it be maintenance or performance. You get all the maintenance counters and things, but from a performance standpoint, you can also latch on to the SAM, which you can then realize some performance from the standpoint of what KAZER is doing. So it's a multi-step answer, which we could probably talk another 20 minutes about. So I'll try to leave it at that for now.
No doubt. I'm sure we could, and I appreciate the very direct answer to the question. So thank you very much. A lot of good info, a lot of good data in there. Stephen, thank you very much for joining us and presenting to our audience.